in Austin visiting a few sites where we have significant problem of Gazania infestation. So this is just outside Loxton town, and that's a grain production paddock. If we can show on this side, so it would have gone into wheat last year, and as you could see, as far as I can see, it's all green stuff that you can see. It's all Gazania. So where they come from, we have on this side, it's along the fence. So it was full of Gazanias, and over the years, it has definitely encroached this grain production paddock. So I just wanted to show you quickly in terms of control and why it's so problematic. So what we're looking at here, so we had this a few years old plant, and when it was sprayed, would have received a few knockdowns. Talking to grower, they went in with some optical spray options, and throughout the fallow season last year they had several non-selective chemicals sprayed on this particular weed, and we're seeing some really effective control. But the problem is, being a perennial species, so where I sort of picked that dead looking plant, it would have been at least a couple of years old. uh, you see these new so-called seedlings coming up. However, it's a bit misleading. So that's not a seedling. So we're looking at a plant that is roughly 8 to 10 leaf, really small looking fragile seedling. However, what it is, it's basically has reshooted from the main plant. So as you could see here, so if we can zoom in, so that's the hard bit of the main mother plant, and this would have come from a rhizome from the same mother plant, and now it's going to become another new plant this season. So if we try and sort of dig it out, and the problem with these shallow sandy soils, it can really get cold quickly, and you don't see a lot of competitive plants around, and that's where Gazanias can get away real quick. The other sort of botanical feature they have and making them really successful is their root system. So even with that rhizome that was attached to the main plant, we could see sort of gone in roughly sort of 6 inches or so. And if we can zoom in, you still see the main root going in pretty deep in this shallow profile, and I haven't been able to still dig it out. So if we pull it out, it just broke. As you can see, it's got its own fully developed root system, and that's sort of really problematic, because what happens on the up, it's looking a small seedling, whereas it's not a seedling. It was uh, a sort of re-sprouting from the main plant that was looking pretty dead, but it has sprouted into a new plant. And with this sort of root system, it's gonna get into become a big plant, produce a lot of seeds. And while talking about seeds, let me just show you quickly. So this is another example. So that's I guess roughly it's another like 2 years old plant, and this would be just a single plant with so much branching. And if you can zoom in, so with these flower heads, it's got on an average 60 to 100 flower heads like this fully grown plant, and each can produce several hundred seeds. And as you could see, this is how the seed gets deposited. So it gets really windy here, but despite that, we could see that some of these bigger grown plants, they have significant amount of seed underneath and deposited there, ready to go. So as soon as we get a rain or a bit of moisture, they're gonna also germinate. And with the shallow soil profile and wind, they can travel long distance. And in our studies, we've seen so far there's literally no dormancy for these seeds. And if we can just zoom here, so that's just how the seed looks. So it's got this fur on it, which it basically is windborne or waterborne, and it can travel long distance, and each would have really high germination flexible requirements, and it can germinate pretty much anywhere. So that's what we're dealing with. But there's some good news. We've been running some chemical control trials for the last 2.5 years. And what we've done here is that we've gone in with a range of different non-selective, selective herbicide options. There's nothing on label so far. So it's been a bit of a, I guess, learning process to what to look for. But we're getting some really decent results and some effective control options moving forward. So if you're really interested to know about this more, please join us for the upcoming GRDC research updates. So I'll be speaking about Gazania, specifically about their biology, how they're spreading into grain production systems and management in Adelaide, and then also in Wakery here in South Australia, and then later in February in Bendigo. So please tune in and reach out if you're interested in knowing about our research or you are able to contribute in some ways. So this work obviously wouldn't have been possible without the help of really super engaged grain growers who had raised this issue. And I think it's really timely that we get on top of this weed before it becomes a real big problem across the grain production regions. So we are really thankful to GRDC for their financial support through an NGN project, which started back in 2023. And that has obviously established significant baseline data. We have been able to map out where Gazanias are real problem in and around grain production systems across the southern grain region. But I've been hearing from a lot of grain growers up in WA and also in New South Wales that they are starting to see some incursions of Gazanias in grain fields. And I'm also thankful to La Trobe University and more specifically La Trobe Institute for Food and Ag that have been really helpful and supportive with this work. So I think with that support and some decent applied research, we would be able to produce an effective management option or package for this weed. But at the end of the day, like most weeds, we will have to move towards IWM and see how we can fit different strategies into the system that will help us get on top of this significant problem. Thank you so much.